episode 2.
Are you done with your yawn? So, who the hell are we to talk about these topics?
Good question.
Who gave us the right?
Good question.
So I talked a lot about my background in the last episode. So I want to get more into your background.
Okay.
So you studied physics, master's, undergrad and master's in physics.
Yeah. So I started actually doing physics, the undergrad and masters. Moved into data science.
What
Yeah.
kind of physics are we talking?
So usually undergrad you do everything, right?
Okay.
Masters you slightly specialize.
Yeah.
I wanted to do a PhD actually, but I never ended up doing it. I'm doing a PhD not in physics now.
Because of your, like, it wasn't a good experience, right?
Yeah,
Your first master's.
I didn't like the sort of master's experience.
But what did, because I remember at some point you told me it was theoretical physics.
Exactly. So my specific field in masters, what I did my thesis on, is called condensed matter physics.
Okay.
So you study the condensed phases, which are solids.
Condensed, so when matter becomes
Essentially,
material.
Yeah, exactly. So you study
Okay.
materials, solids. You also can study liquids.
Okay.
Sort of, if you're the popular materials now, such as graphene. I don't know if you've heard of graphene. It's a 2D material.
No.
So all these sort of popular materials you hear about are technically studied in condensed matter physics.
But what's, like, okay, a 2D material seems like, aren't we,
Flat.
isn't everything 3D?
It usually it's 3D, but then it's essentially two-dimensional because the thickness of that material, which is the 3D, the
Yeah.
thickness part, is very, 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 very small.
But does that exist, like, naturally in the world, or is it something that's, like, experimental?
You can have both.
Okay.
You can have sort of quote-unquote artificial materials, which you do in labs,
Yeah.
but you can also have naturally existing materials.
But, like, where would I come across, like, a 2D object?
2D object.
Or is it, like, really deep in, like, the ground or things like that?
Most of what you see around you is not the typical two-dimensional or one-dimensional that you would do in the lab. Examples of one-dimensional materials are some nanowires.
Okay.
But then most of the typical examples of these, let's say, fun new materials are usually made in in labs.
Okay.
But graphene is made from carbon, so.
But isn't everything made from carbon?
Yeah, I mean, a lot of things are made from carbon. Carbon is.
Yeah.
But graphene is essentially carbon.
Okay, so you were studying condensed matter.
Yeah, I was studying specifically two-dimensional materials as well. I was
Okay.
studying how electrons flow
Okay.
in certain types of these materials.
Okay.
And under certain conditions, these electrons behave as if they're light particles, so as if they are photons, so
As
massless.
if they're light and massless.
Exactly.
Okay.
Very theoretical.
Yeah.
I never went into the lab in my master's.
Okay.
I rarely
Because of
went.
COVID?
It was COVID, but also the nature of my let's say questions were very theoretical.
Okay.
And I wanted to essentially part of me getting slightly away from physics is that sort of disconnect in many areas between what you study theoretically, especially in theoretical physics. So I wasn't in hardcore theoretical physics, but if you do hardcore theoretical physics, such as string theory or gravitational theories or quantum gravity and those sort of fields, you become very theoretical and then you miss the point.
Totally.
I feel you miss the point of physics, and
Like, there's no application to the world we live in.
at least not in the
Okay.
near future.
Okay.
Sort of the energy scales required to test any of these theoretical theories is very, very large, usually.
Okay.
And so I think you end up just being disconnected on the blackboard for 40 years of your life, trying to mathematically derive a theory with a very sort of small possibility of it being tested, which is,
Okay.
I would say, the main reason why I moved away from physics. And I felt the physics that we grew up with, i.e. popular physics, which has its own negative aspects, but then what made most physicists go into physics in the first place usually is what you see on popular physics and quantum physics and gravitational physics. You end up not studying in the way that you would want it. You would want to study it. So I actually moved into industry, into data science, for a brief amount of time. I'm academic by nature, so I ended up going back to academia. But then in industry, I moved closer to data science, to business. And my PhD is precisely a mix of both. So I use methods from data science, from machine learning, natural language processing, all these new buzzwords. But then I apply them to business context. So I apply them to study how markets form.
Okay.
Usually I analyze large, big text data, so millions and tens of millions of textual data, usually on businesses, on places.
Yeah.
And then we try to sort of model them and understand how humans interact in businesses, how markets form, and all of that. So it's more on the AI space now, applied to using AI techniques, applying them into business contexts, basically.
Very cool. So then just going back to the physics,
Yeah.
what would you say, like, okay, the approach to knowledge in physics, how would you describe that? Because I think it's important that, like, when we're talking about like the different modalities or lenses we're going to look at truth in, because truth is relative, we need to know the scope of, like, okay, what is the scope that we should apply physics? What is the scope that we should apply neuroscience? So, like, first, what's the approach to knowledge in physics?
So it's not an easy question. I'll try to simplify it. Short answer is physics, like other natural sciences, share commonalities in the scientific method. Essentially, it's hypothesis testing. You test something. You have a hypothesis. You go to the natural world. You try to find sufficient evidence which support or do not support this hypothesis. Then you generalize the claim. In physics, it's slightly more nuanced because you have a lot of your knowledge is produced theoretically without direct experimental testing. But basically, in an ideal world, in physics, what you would do is you would have a theory, let's say a theory of classical mechanics. If I put this amount of force, I would expect to see this. You would go to some phenomena in the real world, test this experimentally, and then either prove or disprove this theory. It can get slightly nuanced because sometimes the theory is not directly observable. So you'd want to find some, let's say, symptoms of the theory or some secondary, let's say, observations. And an interesting example of this, and you might have heard of it, or some people listening to this might have heard of it, which is gravitational waves.
Yeah,
So
Einstein's
theory of general relativity.
It was just like, I don't like to say proven because nothing's actually proven. I think that's also like language we need to be careful of in science. But like, they found evidence to support the theory quite recently, you know?
Yeah,
like
quite recently,
like
last decade, yeah.
Yeah, like 5 years ago maybe.
A bit
Was it
more,
2023? Yeah. Oh no,
I think
longer.
a bit
Wow.
earlier, yeah.
Time
a bit
passed
earlier.
fast.
But essentially what happened is Einstein 100 years ago had this theory of general relativity, which is, I would say, one of the best again, is slightly, it's a slightly tricky word, but one of the best theories modern physics has to offer, which is Einstein's theory of gravity. Now, one of the implications of the theory is the prediction of gravitational waves. And this is what scientists essentially experimentally found proof for. So you indirectly find proof to support the general theory of relativity.
Which is very similar actually in neuroscience.
Exactly, yeah.
Especially when we're looking at the instruments that we use to measure things. Like, I was talking about how we do these virtual dissections based on an MRI. And we're saying that we're looking at the connections in the brain, but what we're actually looking at is the behavior of water molecules. And from the different ways these molecules behave, we reconstruct an image based on an indirect measure. So it's also like important to note that like sometimes we forget that we're not actually looking at the thing we're making claims about. We're actually using an indirect measure to look at it.
And I think this is a very important point that you just raised, because we tend to think, so I was in natural science, now I'm technically in social science. So the applications that I look at are mostly social science applications. And I think people underestimate how similar both paradigms are, because in natural science we tend to think it's very objective. You're observing what you want to test, but we just kind of indirectly said that it's not always the case. Actually, mostly it's not the case.
Most of the time it's not.
In social science it's the same. You want to try to measure. Example, one of the things I look at is how people relate to places, but I try to do it using big data. So I have big data of people's interactions with places, their reviews, their mobility. And so we're indirectly trying to measure attachment, let's say, to a place or to a business. So it's an indirect measure. We're trying to conclude about their attachment using indirect measures. It's the same with natural science. So I think natural and social science are much more similar than people think. Even if,
I think so too, and it's actually something that we've discussed before, like, I think was it like last week at
Probably,
Flow? Or Fizz, sorry. That it also, because like this question of like natural versus social,
Distinction.
material versus immaterial, it really depends, I think, at the scale you're looking at something in.
Yeah.
You know, because if you're looking at human behavior, like if you zoom out really far, like let's say actually not even human behavior, let's say you're looking at the Earth, okay, from a picture of outer space. You don't see humans going about their day. You don't see them like having meaningful conversations, relationships, pain, pleasure. Like you don't see any of that. You just see like this beautiful rock.
Beautiful.
It used to be, well,
we messed it up bad, yeah.
Yeah. But so then the question of like, I think the question of scale is also really important because like social interaction only exists at this level.
Yeah.
You know, it doesn't exist. Like if aliens are looking at us from outer space, like maybe they wouldn't even know that we have this thing called like socially, like, oh, look at this natural
Rock.
unconscious
Yeah,
thing,
yeah.
you know? So I think for sure. But in that sense, like if we're thinking about like the approach to knowledge with physics, isn't it that they're trying to establish like laws, like fundamental laws that we can then build assumptions from based on the natural world?
It's a chicken and or egg question. You have
Okay.
assumptions. Using those assumptions, you establish laws, but also those laws can lead to assumptions.
It's circular.
It's circular.
Yeah.
So essentially the...
But you have to, at some point, you have to start with assumptions. Otherwise, you're not going to get anywhere.
It's a big debate in, let's say, the epistemic or philosophy of physics approach.
And knowledge in
and
general.
knowledge in general.
Yeah.
But in short, I would say that physics, like most natural and social sciences, is based on a very positivistic view. By positivistic, I mean you have a theory, you test using a hypothesis, and you try to establish a law or a general framework, which applies essentially everywhere. Yeah, so I think it's similar in neuroscience, biology, chemistry definitely.
Yeah. I think the only place you start to have like a distinction, let's say in like academic sciences and psychology,
yeah.
because they take in differing contextual factors a lot more, and the subjective experience. But I think the blind spot there is that even though they're taking into account this subjectivity, it's all focused on the mind as being separate from the body, or the mind living in the brain,
And
let's say.
your definition of mind, or your view of mind, is not brain?
No. I mean, I don't... This is going to open a whole other avenue
To be continued.
of philosophy and debate, but I think that our understanding of awareness, because we're so externally focused, we're disconnected from our bodies, and we operate from mainly relying on our eyes and ears in terms of like sense perception. And in order to be productive, you can't be feeling and be aware of everything at once, right? Your brain is constantly picking up signals in the environment, but it creates a threshold of what enters your awareness or your conscious mind. Does that mean that's what mind is? No, that means that's how the system we've created allows mind to operate. I think that mind and body can't be separated. I think that not in the sense that they're the same thing, but I think that they're parallel systems that are very interdependent. And I think that when we remove language, we start to have a different understanding of what awareness is and what knowledge is. Because language is not meaning, language is not knowledge. It's a symbolic system, a representational system of meaning, of knowledge. But like, that's one level up from what meaning actually is, right? And I think one way to like really illustrate the point is that if you think about thinking, what we're actually doing is describing things. But when you know something, it's a feeling. Like if you're having a conversation, you don't understand each other, then it clicks. You have a feeling, it resonates. You get onto like a harmony or like a frequency with someone of understanding. And before we had language, there were pre-linguistic representation systems. So it's not just that language in our mind tells us what it is. So my point of saying this and how it relates to like whether I think mind is in the brain or not, I think mind is awareness, and awareness is a scope. And I think that scope extends to your whole body because your brain and your body are not separate. I think this is also like a big hang up I have of like having discrete categories of like, okay, this is the brain, this is the central nervous system, this is the peripheral nervous system. Like, yes, you can subdivide them, but at the end of the day, it's all part of one system. Like if I touch this, am I feeling it in my finger? Am I feeling it in my brain? Like, where do you draw the line, you know? So I think that mind exists through the whole body. And because we've spent so long, especially now as adults, we spent our whole lives not learning how to access a wider scope of awareness. So our awareness and our attention span is so narrow and so externally focused. But at least through my experience, I've managed to expand my scope of awareness. Like how I was saying, I feel my body differently. And it's allowed me to access deeper meaning and deeper understanding of myself, deeper knowledge, deeper trust, maybe not in a way that I can put into words necessarily, but in a way that it has significantly improved the quality of my life, you know? Like, I can say it, like, I grew up, like, super depressed as a teenager, you know? Like, I wasn't always, like, happy and energetic and whatever, so, like, really the value I got from you know, changing my perspective of like
mental well-being,
a mental well-being and also the role I play in it and the power I have in it.
agency.
Yeah, the agency I have, like that made all the difference. So yeah, I mean, that's a long way of saying that I think that mind is like, it's not just in the brain, but that's in psychology, it really does localize it to the brain. And yeah.
And I think I think that's a perfect example to show that, you know, we have the capacity to read scientific articles, usually based on the Western method or scientific method that we explained.
Because of our training.
Because of our training,
yeah.
But equally incorporate personal experiences like the one that you just shared into, let's say, bringing different perspectives, such as traditionally called Eastern, but as you said, they're not Eastern. They're all over the world.
They're more like traditional
wisdom.
Yeah.
And try to not essentially say one is better than the other, but just give perspectives, put them out there, explain them.
Yeah, and also it's really important to say that like we think that Western science is the only credible science because it's objective and measurable, but these like lineages of traditional wisdom didn't come about because someone just said like, oh, I think that this is that, you know, like you're talking about like generations of systemic observation, naturalistic observation, case studies.
Essentially, it's millions of case studies.
Exactly, and that is valid scientific inquiry. We use those methods today. We just don't associate them with each other.
Causally, yeah.
So it's really important to say that like it's not like they're just out there like guessing things, you know, like they really are applying systemic observation, and maybe they're not testing it for statistical significance. But I mean, look, in King's College, where I used to work in London, there was like a bulletin board, and they used to have these like lame science memes on them, but I thought they were funny. And one of them said, if you torture your data long enough, it'll tell you what you want it to. So that's a way of saying that like, okay, just because we're using statistics, like you can play with that shit. Like you can really make it like say what you want to a certain extent. So yeah, I think on that point also, because we're introducing the angle of yogic philosophy and yogic science, I think a lot of people don't understand that yoga is a science, and especially how the yogic texts came about. They came from systemic observation of the subjective experience. So it's not like you go into yoga and you just like do whatever randomly. It's a consistent, repeatable practice. So the conclusions they were able to derive from that came from like measured, repeated methods, which is basically the basis of the scientific method. So I think it's also really important to to reframe our idea of yoga or yogic philosophy and science, to have that credibility as well. You know, just because it deals with the internal realm more, it doesn't mean it's less credible than the external realm.